will have to have the function defined. And once you do the inversion, the range of the main function will be the domain of the inverse function, and vice versa. So this is why those two conditions must exist. Also, if I have f from x into y, and I'm getting f minus 1 from y to x, if you do a composite function f of f minus 1 of y, it will be y. If you got f minus 1 over f of x, it will be x. And that's a check on the inversion. That's a check on the inverse of functions. As usual, once we try to go to any topic, we understood, we had a complete understanding that we will have to deal with the various types of functions that we may face. We may face functions in just only one variable. We may face functions in several variables. And we may face functions in vector valued functions, or a function in vector with multiple outputs. Okay. This is going to be the case for the next step. Okay, so if I look to these two guys, for example, I have, for example, if I have y is equal to x plus 1 over 3. This is a function of a straight line. If I want to find the inverse for this function, first of all, it is of course a bijective function. Why it is bijective? Because as you can see, it is injective and subjective. It is injective and subjective. So I can find simply the inverse. How to get the inverse? The inverse, I will get it in two steps, Omar. The first step, I will try to get x in one side. That's the first step. So in order to get x in one side, or to separate x in one side, all I have to do is to make a cross multiplication. So you will have 3y equal to x plus 1, which will lead to that x equal to 3 over y plus 1. That's the first step. The second step, my friend, is to replace each x and y by vice versa. So I would have y equal to 3x plus 1. So just a second. I've moved one, I'm sorry. This is negative 1, I'm sorry. Because you are moving positive 1 from this side to the other side. So in a different, so it's similar to have this guy. That's the inverse. So as I told you, this is f minus 1 of x. That's the inverse function of this function. So if this is f of x, that's going to be f minus 1.
Would it be that cross multiplication to be 3 instead of y?
3 times y. And y is divided by 1. Am I right, Omar?
Yeah.
The y, it has a 1 as a denominator. So if you make cross multiplication, you will multiply 3 times y and 1 times x plus 1. This is going to be the case. Now try to separate x in one side. Then I will have to move positive 1 to the other side. So it's going to be x equal to 3y minus 1. Then I will change the names of the variables. I will call, instead of x, I will call it y. And instead of y, I will call it x. This is going to be the f minus 1. How to check if my words are correct or not? It's really simple. Try to get f minus 1 of f of x. Which means I will take this function, which is 3 minus 1. But instead of x, I will put f of x. What is the f of x, Ya Omar? What's the f of x?
Plus 1.
It's x plus 1 over 3 minus 1. Let's see the result. If you remark, the 3 will be cancelled from each one of them. So, and then you will have x plus 1 minus 1, which is x. And that means it is a correct value for the inverse.
Yes.
So if I have the main function and I've used f minus 1, then this is going to be the result. Let me try to be away from my head. Okay.
دكتور if the x is equal 0
If of x is a,
if the x is equal 0
if x equals 0,
because maybe that b that x equal x plus 2 or x minus 3 or be negative or be, something in the numbers means that x equals 0 or negative.
it will be the case, same case. أنا مش عارف اشمعنى x equal to 0. Why x equal to 0? What I'm trying to get here, I'm trying to get the inverse of this function. Okay? So it has a domain and range. Here I have f of x equal to x plus 1 over 3, which means that both the range and the domain is from R to R. طيب, when you go to the steps, the main steps of getting the inverse of the function, I will start by making the cross multiplication. This is how to get the inverse. And then I will replace the names of each one of them. Instead of x, I will replace it by y. Instead of y, I will replace it by x. That's f minus 1. Remark, Omar, this is also a straight line equation, which have the domain is r and the range is r. Which means the domain of the main function is the range of the function after the inversion and the vice versa. Okay? For all values, it's any values you can substitute with. But this relation, we discovered that if I get f minus 1 of f of x, the result will be x. If I get also in this case f of x of f minus 1 of x, the result also will be x. If you get any value other than that, then it's not the inverse. So this function doesn't have this function or that image as an inverse of itself. Okay? Of course, you will have first to satisfy all the conditions required for making the inversion from the beginning, which are the function should be injective and subjective as I told you. So once more, here we go. As I told you, the first thing that I will check is the possibility of having this change. I'm giving f as a composite of g of x. G of x is running from R to R because g of x is a straight line equation. So that domain is R and the range is R, so from R to R. Also, f is a straight line equation, so it is R to R. The condition for a successful composite function is to have these two guys equal to each other. So if you try to form, as I told you, f of f minus 1, you will end up having x, which means it is the inverse function. Both of them are inverses from each other. I will drive more to check if it is possible to find injectiveness or not, and more examples also. Here for this problem, I have j, which is running from R to R, with expression g of x equal to x squared. From the beginning, I can't get the inverse of this function. Why I can't get the inverse of this function? Number one, it's not injective. Yes, you are right. And also, it's not surjective. Okay? So, it's not. I can restrict the range for this function to be surjective. How to restrict the range, Omar? I would say, this function is going to work, but just only for y greater than or equal to 0. That's the case. See? G is running from R only to R positive and 0. So this guy is not with you. I'm talking about this guy only. I'm talking about the case for all the real set. I'm going to restrict the domain of the function. So the range is equal to the domain in this case. So it's a subjective. But yes, you are right. It is not injective because of the horizontal line. I can restrict the domain. If I restricted the domain, then the function will be running from R positive into R positive, and in this case, this shape of function, with this restriction, it will be injective. And if I want to get the injective or the inverse of this function, I can. So let's try to get the inverse of this function. Okay, in this new slide, here we go. We can only find inversion that are bijective, but if a function is injective, and we can always find, if a function is injective, we can always find its inverse by restricting the codomain to be the range as we saw. If I have, for example, f of x equal to ln of x, يا ترى دي bijective function? Yes, subjective and injective. طيب, how to get the inverse? This is y equal to ln x. Get x on one side. يبقى x will equal to e to the power of y. That's the first step. يا عمر انت فاكر الستبس اللي انا قلت عليهم حالا؟ هما 2 steps. ايه 2 steps؟ وانا عندي هنا y equal to ln x, which leads to try to get x in one side. E to the power of y is equal to x. Second step, y is equal to e to the power of x. That's the inverse function for this shape. So that's the main function, that's the inverse function. ماشي؟ طيب, if I try to check, can you do the check? Yes. Get f minus 1 of f of x, which means f minus 1, that's f minus 1, which is e to the power of f of x, which is ln x. Yes, you are correct. E to the power of ln x is equal to x. So it is correct. Okay, if I want to graph it, you will see the graph shortly, just in a second. So for this example, f is equal to ln of x, or y equal to ln of x. That's gonna be the first. It's an invertible function since it is a surjective and injective function. Y equal to ln x, which means get x in one side. X will equal to e to the power of 1. Then replace each other. Y is equal to e bar x, that's f minus 1. If I try to draw y equal to e bar x shape, that's e bar x. So that's mainly y, or f minus 1 of x, which is e to the power of x. That's y, which is f of x, which equal to ln x. And that's the mirror line. This is the mirror line, which is y equal to x. This is why once you get f minus 1 as an f of x, the result will be x as you saw previously. 9? Okay. Very good. Second.
16.
ايه 16.
11.
Okay. ماشي. F from R to R, g of x equal to x squared, so it's not invertible function, since it is not surjective nor injective. I can, as we knew, that we can restrict the domain of this function. So y will be equal to x squared in the restriction from r positive into r. In this manner, I can get x equal to root of y. Then I will replace them together. Y is equal to root of x. That's f minus 1. So if I want to draw, this is y equal to x, and those are the two lines, the two curves. This curve is f of x equal to x squared, while x is greater than or equal to 0. And on the other side, this curve, this line, it is y equal to root of x, which equal to f minus 1 of x, as you can see. And also it is in x is greater than or equal to 0, as you can see. You can also remark that the mirror line, this is the mirror line, is passing in between these two curves, as you can see. Okay. So, once more, this is also an example on how to get the injective of, or how to get an injective value of this function. Now, if I have vector valued function, and if I want to get the inverse, it may look to some as a complicated case, but no, it's not complicated. It's really very simple. All I have to do in such a case is to be sure that this is an injective and surjective function. It's an injective function. And by the definition, if you look for the injectiveness, this is x squared plus y squared, x squared minus y squared. So, and it is running from r positive and 0, so it's taking the positive side for both of them. So I can't substitute here by negative 2 and negative 3, for example. I'm just substituting by positive values, so it's an injective function. For surjective, the whole codomain is covered by these two values. Because this is positive and that one guarantee that the difference will appear negative signs. So it is an injective and also surjective. This is written here, xy, except x is greater than, or it is the domain, x is greater than 0, y is greater than 0. So the domain is restricted. If we consider Rf denote the range of the function, y equal to, if we let u equal to x squared plus y squared, and the v equal to x squared minus x squared, and those two values are guaranteed at the cover of the codomain. That's the range of f, from which we can know if the codomain is covered or not. The range is equal to r squared, except y is greater than, u is greater than or equal to 0, because it is always positive, so this relation is positive. Also, u is greater than v, and u plus v will be greater than or equal to 0. That's from the restrictions given in here. So, if I want to get the inverse, if I want to get the inverse, I will call f1 u, f2 v. This is for the first function, and that's for the second function. Try to solve these two equations to get x as a function in u and v, and y as a function in u and v. If I want to do this, this is really very simple. All I have to do, let us sum u plus v, get the addition of u plus v. If you add the u to v, what's gonna be? بص كده يا عمر, if I add them together, ايه اللي يحصل؟ هيبقى u plus v equal to x squared plus y squared plus x squared minus y squared. These two values will each other, and you will have u plus v equal to 2 over x squared, which leads to an x squared equal to u plus v divided by 2. Okay, so I can take the square root for this value, and I already have a condition for x. It must be greater than or equal to 0. So x is equal to the root of u plus v over 2. Are you with me?
Yeah.
A similar debate can be done if you get the difference between u and v. So I can do a difference between u and v also and get the result. If I do so, the difference between u and v, this is gonna be, that's the addition, and that's the difference between u and v. You will get y squared equal u minus v over 2, which means y equal to the square root of y minus v over 2. That's the x and that's the y. Now the inverse. It's gonna be f minus 1 of u and v. F minus 1 of u and v. So all I have to do, Omar, is to get f minus 1. Instead of the u component, write the first component. Instead of the second component, write the second component. So actually, this is f minus 1, which is the root of u plus v over 2, u minus v over 2. طبعا, remark, Omar, if you replace, if you make a composite function of f minus 1 of f of x and y, you will replace u by x plus x squared plus y squared and v by x squared minus y squared, and then this is gonna be terminated to reach x and y. Okay, and that means that check is working exactly. Okay, here's what I mean. Here's the two values. If you make the substitution by the values that we have, then the two roots will disappear. Okay. Okay, that's another example which exists in the many slides in the trench of 396. That's also a vector valued function of an f of x, y, x minus y, x and plus y. In order to get the inverse of this function, of course, it is bijective. Why did I say it? Of course, it's bijective. Because it's two linear relations. So, what to do? I will call this guy u, and I will call that guy v, and I will try to get u, x, and y as functions in u and v. So once more, the function is a bijective function because it's a linear function. Okay, I will get u equal x minus y, vx plus y. Then let's add them together and get the value of x. If I added these two values together, I will be able to get x. If I subtract it from each other, I will be able to get the value of y. Once more, I'm adding them together. X plus v is going to be x minus y, x plus y. These two guys will eat each other. So u plus v equal to 2x, x equal to u plus v over 2. Keep this in mind. Keep this in mind. In a similar manner, u minus v is going to be x minus y minus x plus y. And in a similar manner, you will be able to get y as v minus u. Now I have the two components, x and y, for this function. So I will continue getting the f minus 1 of u and v. If I make the substitution in the main function, but these two values, بص كده يا عمر، هشيل u واحط مكانه x minus y، هشيل v واحط مكانه x plus y, it will be disappearing and leave you with x plus y. Exactly like getting f minus 1 of f of x, the composite function. This is exactly how to get the inversion and to be sure about your check and everything. Remark that it can come to you as multiple choice and you can choose the thing. Now I want to talk with you in specific about the composite function. Remark that through our work in the inversion, we had to make the check of f minus 1 over f of x, or getting the function of u and v. So we really need to understand more about the composite functions. This part is dedicated mainly for the composite functions. So if I have, for example, this problem, it's also a very nice problem. I have g, which is running, which is the domain of g from r to r. G of x is given by this function, which is a square root 6 minus 0.5 x squared minus 2. And f of x is given by f of x equal to the x. That's the shape of the x. As you remark, the function of len of x, it needs to be, the domain should be in the positive side. What's the representation of this function? This guy, how to be represented? First, the root of 6 minus 0.5 x squared, if I put this y, I will have y squared equal to 6 minus 0.5 x squared, which is going to be y squared plus 0.5 x squared equal to 6. And that's a shape of an equation of a half circle, semicircle, running from, an ellipse like a circle, or very close to a circle. Okay, but I'm talking about the semi shape of this guy. If I want to get the domain for this function, I can. From the previous lecture, what should we do to get the domain, يا عمر؟ إيه اللي إحنا عملناه عشان to get the domain? I will have to see the condition. What's the condition here? The condition is 6 minus 0.5 x squared must be greater than or equal to 0. صح? Which means 6 must be greater than or equal to 0.5 x squared. Which means x squared must be less than or equal 12. That's x is less than or equal the root of 12 and the greater than or equal negative the root of 12. Which is going to be x less than or equal 2 root 3, am I right? Greater than negative 2 root 3. So if I want to grow or to graph it, it's going to be, this is the x-axis, that will be running from 2 root 3 to negative 2 root 3. But don't forget that this is not the whole function. The whole function is, it's subtracted from it, we subtract negative 2. This is why the domain, or the range of this function, it moved 2 steps down. It moved till the line of negative 2. And it will be cutting the x-axis, as you can see, at 2 and the negative 2. This is really very simple to get also. By just making or equating this equation to equal to the root of 6 minus 0.5 x squared, and then try to solve for x. It will be 4 equal to 6 minus 0.5 x squared, which means you will have negative 2 equal minus 0.5 x squared. That leads to x squared equal 4, يعني x equal positive or negative 2, exactly the 2 points that I told you about. If I took these values and substitute in g of x, Okay? If you substitute by 2, the y is going to equal to 0. If you substitute by -2, the y is going to equal to 0. If you substitute by x equal to 0, you will get this value, which is √6 minus 2. Yeah? Okay, remark in the composite functions, the range of the first function is the domain of the second function. Let me tell you once more. The range of the first function is going to be the domain of the second function. So, if you remark from here, that's the range. That's the range of the first function, of this function, which is going to be the domain of the len. This is why this is the part of len that you will deal with. That's the domain of your composite function. So, if I want to do it as we experience it step by step once more, this is g, and that's an f of x. The second step, getting g combo f composite g, sometimes I call it f after g. It's going to be len of a root over 6 minus 0.5 x squared minus 2. This is why I will have to satisfy both the condition of the inside function and the outer function. The inside function domain is running from -2 and +2. And the outside will eliminate -2 and 2 from your suggestion. So the domain of all of this is how to get the domain as we did exactly, knowing that it's between -2 and 2. That's the range of g, the range of the inside function, which is from 0 up to √6. If I want to see from 0 up to √6, that's the function defined. Okay, the condition is to have the len will reject the values of 0. That you can substitute in len with 0. And so this is going to be the domain of f composite g. Usually in these problems, you will be asked to identify the domain of f composite g as you will see. That's also another problem on the composite functions. As you can see, this is a multi-variable function. It's running from R2 into R, where G is running from R to R. Here, there is an important condition I should check, which is I have to check if it is possible or not. Because F takes a R2, develop R. G, it's moving from R into R. So actually I can get F, okay, I can get G of, I can get G as a composite of F. But the inverse is not going to be possible. Let's see. If I want to get the G composite F log to this function, it's from R2 into R. And for G to work, it's from R into R. So I can get G as a composite of F. I can't get the inverse. So XY, if I want to get G as a composite, all I have to do is to do the following. G composite F. It means the domain of F is going to be, the range of F is going to be the domain of G. So I have to do this check. If I want to do this, it means, بص كده يا عمر, look to G as a function in f of x, which means G composite f. Let's look to this function. It's running from R into R. Am I right? No, I'm not right. This is from R2 into R. And then I will look to the outer function. The outer function is running from R into R. بص على G from R into R. Are you with me? خلي بالك النقطة دي كويسة قوي. لازم الاثنين دول يساووا بعض. These two values equal to each other. Which means the range of the first function is the domain of the second one. فاهمني يا عمر؟ طيب أنا كده جبت G كومبوزيت F. هل تقدر تجيب F كومبوزيت G؟ يعني F ومين اللي جواها؟
G.
طيب تعالى كده بالراحة نشوف. هي G رايح منين لمين؟
G من ال
R لا طب والإف؟
من R to R.
من R2 دي F اهي. من R2 ل R. هل الاثنين دول بيساووا بعض؟
لا.
يبقى it is not defined, it's not possible.
اوكي.
لان بص كده اكيد عارف دي دايما بمثلها بايه؟ اما يبقى عندك عارف لما تيجي معاك كابل، اوكي، معاك كيبل في 3 مخارج
مظبوط.
ماشي، وعايز تركبه في فيشه فيها 2. في الحاله دي مش هتعرف، لان هيفضل عندك خط انت مش عارف تعمل فيه، صح؟
مظبوط.
طيب لو انا عكست، يعني لو عندي 2 في حين عندي حاجه 3 فاس، مش هعرف اشتغل، لان هتوصل دول ازاي؟ الانبوت اللي هنا ب2، لكن هنا انا اسف الاوتبوت اللي هنا ب2، لكن الانبوت اللي هنا بكام؟ ب3. طيب دي تعال بقى بص هنا، ده الاوتبوت بكام؟
1
بار. هنا الانبوت اللي بره، ما هو الاوتبوت بتاع اللي جوه هو الانبوت بتاع اللي بره. الاوتبوت بتاع اللي جوه بار، الانبوت بتاع اللي بره بار، ينفع يركبوا على بعض. لكن تعالى لي هنا الاوتبوت بتاع اللي جوه ار، في حين ان الانبوت بتاع اللي بره كام؟ ازاي هينفع؟ ما ينفعش. تمام؟ يبقى اذا ده تشيك مهم جدا لازم تخليه في بالك، لانه احيان كتير هو ممكن يسالك على بروبلمز تنفع تجيب اف كومز جي، بس ما ينفعش تجيب جي كومز اف او فايس فيرسا. So in a similar manner، نفس الاسلوب بالظبط. This is G which is x of y which led to let x plus root of y. So domain represent the domain with respect to both f of xy and g of x should be satisfy both conditions. So it will satisfy first that the condition here y must be greater than or equal to 0. And for this guy to work, both the functions which is inserted here instead of t, that's x plus root y, both of them should be greater than 0. If I have y greater than 0 and also x plus root y is greater than 0, these two conditions must be satisfied. Can we get f comes g? تعال نشوف. لو انا جيت اجيب f comes g I will have g of x and then of f. طبعا مش هينفع، وهنا طبعا بيقول لك ال r g from r into r، لكن التاني from r2 into r ما ينفعش يركبوا. Those some examples اهو as you can see. This is from r to r into r to r. So if I want to get f comes with h, it will be possible. If I want to get h comes with f, also will be possible.
Okay.
The domain, once he asks you about characterization, he needs you to find the composition and to find the domain of the composite function. So the first step, Omar, is to get f as an h of x. So all I have to do is to get the outer function, and that's the inner function. The inner function is not going to work unless x is greater than or equal to -1 because of the root. The outer function doesn't have any problem, so the result will be x minus 2. So if you have a composition f comes with h, it will be x minus 2. What about the domain? The domain is exactly as I told you. X plus 1 must be greater than or equal to 1, so x must be greater than or equal to -1. I can write x belongs to r such that x belongs to from -1 up to infinity. This is to secure the domain of the root function. Another problem, getting h as a composite of f, and also it is possible. All I have to do is to get h and replace x in here by x squared minus 3. If I did so, Ya Omar, I will have, instead of x, x squared minus 3, negative 3 plus 1 is going to be negative 2, and then I will have to be sure that x squared minus 2 is greater than or equal to 0, which means x squared must be greater than or equal to 2. And that's x is greater than root 2 and or x is less than negative root 2, which means x belongs to r such that from negative infinity up to root 2, union from root 2 up to positive infinity, that's the domain. Also in this function, stop. In this function, you need to discuss what we mentioned previously. This function is from t to t, from r to r. But this one is from r2 into r. So let's check about if it's gonna work or not. So if I want to get f as a composite g, f is gonna be the outer function and g gonna be the inner function. The inner function will run from r2 into r. The outer function from R to R, remark they are equal to each other, شايف? Equal to each other. Then it is possible. Yes, I can. طيب, how to do it? I will take the function which is 1 minus x squared minus y squared. This value, I will put it inside the root. So now I will have a root of 1 minus x squared minus y squared. To get the domain, يا عمر, I need to have this value positive. طيب, enter this value to be positive. Now 1 minus x squared minus y squared is greater than or equal to 0. طبعا, move these two guys to the other side. The x squared plus y squared is greater than or equal to 1, which means inside the unit circle. So all the points inside the unit circle are involved in your domain. Okay? So that's the domain. X, y belongs to R squared, such that x squared plus y squared is greater than or equal to 1. طيب, can I get G as a constant method? تعالى check. يبقى G برا وF جوه. F from R to R. لكن G from R2 into R. يا ترى دول بيصلحوا؟ لا. يبقى إذا no we can't. Okay. That's another problem, but it's an easier one. He wants you to choose and that one of the problems who came previously in one of the exams. He wants you to find H comes G at number 4. Which means, if I want to do this, I will need to get H of G at 4. Then first try to get G at 4. So I will take this guy, and it's going to be G at 4, which is equal to 8, divided by 4 minus 12, which is going to be negative 1. Then I will take the negative 1 and insert it in here, so it's going to be H of negative 1. Which means negative 1 minus 9 over 5, which is going to be negative 2 or something like this. So once more, if I want to resolve it, can I do the composition? Yes, you can do the composition. Because mainly it's two straight lines. So it's running from R into R, from R into R. So they are equal to each other, as you can see. Okay, the second step, G at 4 is equal to negative 1. So H at negative 1, once you substitute, will be negative 2. So I will choose negative 2. That's also another problem who came